Hi guys, let's solve this differential equation question, which is based on Newton's law of cooling. Right, we have done the proof of this, or we have derived this two formulas in our previous video. So now we are going to use this in our question. So let's read the question. An ice pack was placed in a chiller set at 4 degrees Celsius. The ice pack was originally at 37 degrees Celsius and it cooled to 29 degrees Celsius in 16 minutes. Assuming that the rate of cooling is proportional to the temperature difference between the chiller and the ice pack. So this line is actually just the actual law of cooling. Calculate the temperature after 60 minutes. Right, so let's see what information we have. So we have that T of the chiller, which is the ambient, which is the environment, is minus 4 degrees Celsius, right? So originally it says that originally means when time was zero. When time was zero, the temperature, the normal temperature was 37 degrees Celsius. All right. So with this information, if we substitute this value, this is just the original bit that we have. So we have T is equals to TA plus CERT. Now we have two unknown values there. We have C, which is unknown. We have R, which is unknown. We don't know what time. It's given 16 minutes. We might have to use it somewhere. TA and T is given to us, right? So here and here, for this case, time is 0 as well. So we have time. So T is 37 degrees is equals to TA is minus 4 plus, we don't know what C is. R we don't know, but for the original value or the initial thing, time is 0, right? So e to the power of 0 is 1. So we'll leave it there. So 37 plus 4 is equals to C, which will give us C is equals to 41, right? These are temperatures, so it's 41 degrees Celsius. So we've got the value of C. Now let's go back to the question and see what we have. So the next bit that we have here is after 16 minutes, right? So let's write it there, after 16 minutes. So now in this case, time is 16 minutes. New T value, the T value has now cooled down to 29 degrees Celsius, right? And our ambient, our environment is still at minus 4 because it's a chiller. That temperature is not changing, all right? And we have also found that C is equals to 41 degrees Celsius, right? So we have all this information. Let's put it back in the equation, in the general formula, and let's find R this time. CERT. So T is 29, TA is minus 4, plus C is 41, E to the power of R, which we don't know, but we know T is 16. So this will now give us 29 plus 4 is equals to 41E 16R. So that is 33 is equals to 41E 16R. 33 over 41 is equals to E to the power of 16R. We know that to get rid of exponential, we can do ln on both sides. So ln values are always positive. So it's modulus 33 over 41 is equals to ln E 16R. That can be cancelled. ln 33 over 41 modulus divided by 16 is equals to R. All right, when you put these values in your calculator, you will end up R is equals to minus 0.0135. Right, so put that in your calculator, you'll get that answer. Now this is our R value given to us that we have found. Right, so now we have mostly all the values that we want. Now we can find what they are asking. So they are asking us that the temperature after 60 minutes. Right, so let's go back. Now we are solving a temperature after 60 minutes. All right, so now same formula, TA plus C E R T. R is negative because it is cooling down, right? Something is cooling down. That's why the rate is negative. Now here, T is, so temperature after 60 minutes. So here we are going to take TA as -4, which we know is -4. T is what we are finding. So T is equals to -4 plus C is 41. We have already found e to the power of -0.0135, and time is 60 that they have asked. So T is equals to -4 plus, you can put all the values in your calculator and you should end up with the answer that is required. So you don't have to write that again, but you will end up, if you put all those values in your calculator, you should write calculator, you will get your answer as 14.2 degrees Celsius. Right, so that will be the temperature after 16 minutes. Now the next part is, they are asking, next part of the question is the time. So we have to find the time to cool to within 1 degree Celsius of the chiller temperature. So within 1 degree Celsius of chiller temperature means that if the chiller temperature is -4, it is less than -3 degrees Celsius. So it is somewhere between -3 to -4 degrees Celsius. Right? So here again, T is equals to TA plus CERT. Your T value is somewhere between -3 to -4. So we can take any value. I'll take something closer to 4. So let's take -3.9. Right? Just closer to that. So that will be now -3.9 is equals to -4 plus, and you can take any value, doesn't matter, because they have given you a range. You can have a range of answers. 41 e to the power of -0.0135. Time is what we are finding. So that will now be -3.9 plus 4 is equals to 41 e to the power of -0.0135 t. This is going to give us 0.1 is equals to 41 e to the power of -0.0135 t. That 41 is divided, so 0.1 divided by 41 is equals to e minus 0.0135 t. You can do ln on both sides. So ln 0.1 divided by 41 is equals to ln e minus 0.0135. Don't do that mistake that I am doing of getting that 0 away. 135 t, that's gone. So ln 0.1 over 41 divided by minus 0.0135 is equals to t. Right? Use your calculator and you should get a value. And this will give us 445.6 minutes. Right? So this is when it is very close to -4. You can do 3.9 as well, which will give you a slightly different answer. Right? So you can have a range of values or any value between -3 and -4. Just keep in mind you cannot have -3 there, because if you use -3, then 4, when moved to the other side, 4 will give you 1, and ln1 is 0. So try and not use 3, but any value after that, 3.1, -3.1, -3.5, any of those values in the range would be fine. All right, so that is the answer. Cool. I hope this makes sense. Have a good day.